All right, welcome to Chapter 6, which will be our last unit for the year here, which deals with representing patterns. So we're going to go through 3 examples here today. I'm going to show you how to do these types of questions, and they're actually fairly similar to each other. So once you get the hang of one, the steps apply to basically all of them. So first, quick term here. A linear relation is a relation that appears when a straight line when graphed. So the idea is eventually we're going to get into graphing on the x-axis, y-axis. We're going to graph some values and they will make straight lines. So these are all linear equations. That's kind of what's being introduced here in this unit. Alright, so this is what the examples kind of look like. It says describe a pictorial pattern using a linear equation. So we have a square, and each time there's more squares you can see the pattern. We're going to try and dissect what the pattern is, write an equation for it, and then predict what the pattern would look like if we continue to draw it for many more figures. Okay, so we're going to just kind of go through this together here. So first off, describing the pattern. So you can use your own words for this and make it as detailed or as kind of simple as you want. But basically, if we start at figure 1, how do we get to figure 2? And then how do we get to figure 3? Like what's the pattern? So you can see we added 3 blocks to figure 1 to get figure 2. And then when we start here, now if this was figure 2, right? Then we add 3 more blocks to get figure 3. And then our figure looks like this, and we add 3 more blocks up here. So what's the pattern? We can say something like 3 more blocks added to the top right hand corner of each figure. Excuse my writing here. I haven't quite got the hang of this stylus here, but so something like that, right? We add 3 blocks and then we get the next figure. All right, so then let's look at question 2 here. It says create a table of values to represent the linear relation between the number of squares and the figure number for the first 4 figures. So this is important. This is what we're going to do a lot. Okay, so we have to make a table for part B. So what I'm going to do here is we're going to go figure, and figure just means like shape, and we're going to call that F. Okay, and then we're going to make a table figure versus number of squares. And we're going to call that N. Okay, you can use any letters you want, but it's always good to use ones that kind of make sense with the question. So let's make a table here. So figure 1 has how many squares? Well, you look up here, figure 1 has 1 square. Easy. Figure 2 has how many squares? 1, 2, 3, 4. And we're going to keep going. So figure 3 has 7. Figure 4 has 10. Okay, so now what we have to try and do, so there's our table of values. We're done part B, technically. Now we're going to use this to create the equation. So part C, it wants us to have an equation with 2 variables. Okay, in this case F and N, representing figure number and the number of squares. So that's our goal here. So we're going to use the table to get an equation. So I'm going to show you how to do that. So what's a pattern here? So obviously figure number just goes up by 1. Number of squares goes up by how many? So 1 to 4, that's 3 spots, right? 4, 5, 6, 7, that's another 3, 8, 9, 10. So this is going up by 3 each time. But obviously it's not just counting by 3s because we're starting at 1. So we have to figure out how can we make an equation to go from F to N. And the answer is we're going to use this number. Okay, so we always start with the easiest one. We're going to use the 1 and 1. I'm going to use this 3, and I'm going to times it by the figure number. And then I want to get 1. So here what I'm doing is I use this 3, I'm timesing it by this 1, and then I may have to add or subtract something, we're not sure yet, and our answer needs to be 1. So 3 times 1 is 3, right? How do I get to 1? Well, I subtract 2. Okay, and then all we have to do is test this for one more and see if it works. So let's test it on this big one. 3 times figure number, so that's 4. Subtract 2 equals, if we did it right, it should be 10. So 4 times 3 is 12. Subtract 2 is 10. Done. Okay, so our equation that we're going to write as our final answer is 3 times f subtract 2 is n. And you don't have to put brackets around the variables, but sometimes it helps keep it straight. Okay, I know we went a little fast there, and we'll do another example in a second, but we basically figure out what it goes up by, and then we use that number in our equation. Okay, so 3f minus 2 gives us n. So now let's look at D. How many squares are in figure 12? And the reason why we want this equation is to figure out this, right? Or to determine these bigger numbers. Instead of you having to draw figure 5, 6, 7 and get a bigger and bigger shape, we're going to actually just use this equation. Okay, so I'm going to do D on the next page here. So D says, how many figures are in figure 12? So a reminder, our equation we figured out was 3f minus 2 equals n. So figure 12. Okay, so we're going to plug in, instead of f, we're going to plug in 12, because that's what the question asked. Minus 2, and when we solve it, we're going to get the number of squares. So we have 36 minus 2 equals n, so n equals 34. So if we go back to our question here, figure 12, if we kept drawing this, would have 34 squares. Okay, and lastly, E, which figure number has 106 squares? Verify your answer. So let's just figure that out here. So now we're going backwards. So we're going to use the same equation, okay, but now it gives us n. It tells us that the figure number has 106 squares. So I'm going to plug in 106 instead of n. And now I just solve it. So basic algebra here. So we'll add 2 to both sides. So I get 3f equals 108. Divide by 3. Divide by 3. And we get f equals 36. So the 36th figure, if I drew 36 of those things, would have 106 squares. Okay, so the steps we took here was we recognized the pattern, we made a table, we used the table to determine the equation. That's kind of the hard part. We'll do a couple more to get the hang of that. Then we use the equation to either solve for one or the other variables. All right, and the textbook does explain it here. I'll include the answer. It's on one of the first pages of chapter 6, so it explains what we did. It explains that we figured out that we have to multiply n by 3 and then subtract 2 from the result. So this is just a slightly different way of explaining that table, but we did get the same equation, and then they just show the substituting there. Okay, let's do another one here. It says write an equation to represent the number of circles in relation to the figure number. So it's very difficult to just immediately write an equation. Usually we'll have to do at least a quick table, okay, to get that number, until we get the hang of it at least. So what I would suggest is, even when it says equation first, we want to actually start with a table. So figure, and we can use f again, versus number of circles. And you can use n for number, or you can use C for circles, something that makes sense to you, that you'll remember what you did. Okay, so figure 1 has 1 circle, figure 2 has 3 circles, figure 3 has 5 circles, and figure 4 has 7 circles. Okay, we're done the table. if we had to, let's say it said predict the next value, how many would figure 5 have? Well, we're going up by what? 2, right? Every time we're going up by 2. So they would have 9, because we follow this pattern. Okay, but instead of going up to, you see we have to find 83 eventually, we're going to make an equation so we don't have to make this table go on forever. So what we do to get the equation is we find this number. What did we go up by? Okay, so in this case it's 2, so we're going to go 2 times f, and we're trying to get it to equal c. We're trying to use this 2, multiplying it, we're always multiplying it by the figure number, and then we may have to add or subtract something to get c. Okay, so let's see what happens here. So 2, let's start with the easy one, times 1 gives you what? 2, obviously, right? So then how do you get to 1? Subtract 1, and that gives me 1. So we're very close to our equation. Let's just try a bigger one. So 2 times 4, let's say, we'll do this one, minus 1, it should give me 7. So 2 times 4 is 8, minus 1 is 7. Correct. So then my equation becomes 2 times f minus 1 equals c. Okay. Hopefully that makes sense. I'm not sure I'm going too fast. But again, please let me know if you have any questions. I can do a couple more examples or show you what's going on. But unfortunately, there's not a great way for me to write it all in one step. But you figure out what it goes up by, you times it by the figure number, and then you figure out sort of what else you have to do to it to get back to this number. It's a little bit of a circular process, but we have our equation. Okay, so let's see part B. How many circles are in figure 71? So if we have to, figure number is going to be 71, and the circles we're trying to find out. So we're going to use our equation. So 2f minus 1 equals c. And instead of f, we're going to plug in 71. Okay, so we'll do a bit of math. So I get 142 minus 1 equals c. And I get 141 equals c. So figure 71, if we kept drawing that pattern, okay, forever and ever, eventually we would get where figure 71 has 141 circles. Okay, that was part B. And then part C, we'll finish off here. Which figure number has 83 circles? So we just have to basically figure out which one we're plugging in, right? That's why it's important that we label them something that makes sense. So which figure number has 83 circles? So this time we're trying to find the figure number. We don't know the figure number. And we know the circles is 83. So we'll use the same equation, right? 2f minus 1 equals c. Except this time we are going to plug in 83 on that side. Okay, so just pay attention if we're plugging it into which variable you're plugging in. And then this one has like maybe one more step of math to do, but no worries. We're going to add 1. 2f equals 84. Divide by 2. And I get f is 42. So that means that the 42nd figure would have 83 circles. Okay? Let's try one final question here. This is actually the first one in your assignment, so kind of do this one with me. Describe the relationship between the number of regular octagons and the number of sides in this pattern. So think about these as like tables. So how many sides are actually exposed? So basically we're not counting, and it's very hard for me to draw here, we're not counting these middle sides. Okay, so you're just counting around the whole shape. Okay, so let's do this together here. So and sometimes it's easier to do A and B at once. Let's like make a table. So the number of octagons, so this is A slash B. I'm actually going to call this N for the number. And the reason why I don't want to call it O is because O looks a lot like 0, and then that kind of can confuse us. So number of octagons we're going to call N, and we're going to verse the number of sides, exposed sides, which we'll call S. Okay, so the first one here has only one octagon, and it has 8 sides. The second one has 2 octagons, right? The octagons are going up by 1 each time. That's hopefully pretty obvious. But how many sides did it have? Well, if you count around, okay, not counting the middle ones, we get that it has 14, which makes sense, right? Because if they were separate octagons, they would each have 16 sides, but because we're putting them together, it's getting rid of those middle sides. Okay, so a couple different ways you can sort of figure that out. Let's keep counting. Octagon figure 3, which has 3 octagons. How many sides does it have? If you count it up, I get 20. Double check that for me. And then the last one there, I get 26. Okay, so what's the pattern here? Well, it's going up by, what's it going up by? It's going up by 6 each time. So you can explain that for part A. So for each octagon being added, the number of exposed sides goes up by 6. Okay, I'll let you write that sentence. So B, we made a table of values, so we're done A, we're done B. Write an equation. So here's where we have to play around. So our goal is we have to go something times N, and on the other side of the equal sign we have to get S. So we have to go from this octagons to sides. Okay. Now, one of those numbers we know is this one. So that is going to be multiplied. And that goes here. So 6N equals S. We're so close. What do we then have to add or subtract to make this true? Okay, so I'm going to actually plug in the first one. So I'm going to go 6 times 1, and I have to get 8. So 6 times 1 is just 6. How do I get to 8? Plus 2. So we're pretty sure this is our equation. 6N plus 2 is S. Let's just do a quick check with, let's say, this bigger one. So 6 times 4 plus 2, what does that equal? It should be 26 if we're right. So 6 times 4 is 24, plus 2 equals 26. So this is our equation. Okay, a couple different ways of doing that. Hopefully that makes sense. That's kind of the hardest part, to jump from the table to the equation, but I believe in you guys. So let's continue on here. So 6N plus 2 is S. So then for explain what each variable represents. Well, N represents the number of octagons, S represents the number of sides. You can kind of write that out. And then D, how many sides would a shape made up of 17 octagons have? So if we kept doing this, and we had 17 octagons, basically, what would S be? So we're going to go here, 6N plus 2 equals S. 6 times 17 plus 2 equals S. And I get 104. Okay, so if we had 17 octagons, they would have 104 sides. That was part D. And part E says how many octagons are needed to make a figure with 722 sides. So it gives us now the sides, as 722, and we're trying to find n. So go back to our equation, 6n plus 2 equals s, and then we'll plug in what we know. This time we're plugging in s because they gave us that one, and then we solve it. So minus 2, 6n equals 720, divide both sides by 6, and I get number of octagons would be 120. So if we had 120 octagons lined up in a row, they would each have, the entire figure would have 722 sides. Alright, so that is basically it for this video. So let me know if there's any questions. I'll post the textbook assignment on the website, and then in a couple days, if people have questions, I can go over some specific ones with you as well. Awesome. Good luck. Let me know if you have any questions.